Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out, and I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody. Welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And I just love what we get to do, which is support you in this journey that you're on. We are here to help build competence and confidence in you. And so if you have that competence, but you're just not confident in your math skills, that can affect your test score. And if you have all the confidence in the world, but you just need a little brushing up on those math skills, that can affect your test score. And so we're here for a mixture of both. So I love what we get to do. I love that we are here every Wednesday just serving you. One of the ways that we try to do that is by including questions that you specifically want. And so I always have a next week section here. And if there are topics or questions or things that you want to see me go over in the upcoming weeks, just let me know. That is one of my favorite things to do is include topics or questions that people want to see in the upcoming weeks. So if there is something that you want to see in the upcoming weeks, just let me know. Don't hesitate to let me know that. Before we get started, I always like to do a get to know you question. It makes it feel a little less like a computer screen and a little more like we're doing math in a coffee shop. And so let me know in the comment box where you're from, what test are you prepping for, and the get to know you question. What was your favorite subject in high school? Or like in school in general, what was your favorite subject in school? Mine clearly was math. If you asked me when I was in kindergarten or first grade, I would have said lunch. Lunch was always a favorite time of day for me. It still is. But math was definitely always my favorite core subject if I had to pick one. But I also recognize that we're not all math people, and that may not be all of our favorite. Social studies and history was definitely not my favorite and not my strongest subject. I got through and I was fine, but definitely not my favorite class to go to every day. But I know that there are people who live and die for that. And so We're just all different, and that's okay. So let me know in the comment box where you're from, what test are you prepping for, and what was your favorite subject in school. We will go through about 10 problems. If you have any questions, don't hesitate to ask. And without further ado, let's go ahead and jump right into the first question. What is the volume of the figure that would be created from the net shown below or to the right? What is the volume of the figure that would be created from the net shown to the right? So for volume, remember, we're trying to figure out how much stuff can go in the box, right? Or in the shape. And this is clearly not a 3D shape. A net, and this, even if you don't have to know how to find volume, you do need to know the vocabulary of some of this. So a net is the flat 2D version of a 3D shape if I were to flatten all of its sides or like faces out. And so when I flatten a rectangular prism out, this is one way that the net can be displayed. And so this is what it might look like. It could look a couple of different ways. A net for a rectangular prism could look a couple of different ways, but this is one way that the net of a rectangular prism could look. Now, when I draw this rectangular prism, there's my rectangular prism. If this side is 7 and 8 and 12, how would I find the volume of that rectangular prism? We know that the volume of a box is length times width times height, right? Length times width times height. Why is it length times width? Because the volume of a prism in general equals area of the base times height of the prism. And so if I'm looking for area of the base, area of my base of my rectangular prism is length times width, because the area of a rectangle is length times width. So if I'm trying to do volume of a rectangular prism, I'm going to do length times width times height. So in this case, I'm just going to do 7 times 8 times 12. I'm going to use my handy dandy calculator. (672 feet cubed. So my answer is D. Now, what if it said, what is the surface area of the figure that would be created from the net shown to the right? What if it said, what is the surface area of the figure that would be created from the net shown to the right? Well, we know surface area of a 3D figure is the flat part, right? The 2D area of all of the faces of my 3D figure. And so if they give me this 3D figure in a flat version, then I can easily find the surface area. Surface area is area of all of these shapes. So I know that this side is 8. So that means that this side is 8, just knowing that these shapes are rectangles, and this side is 8, and this side is 8, right? I know that this is 12, so all of these are going to be 12, and I'm actually going to use a different color so that we can see this a little better. So if this is 12, then this is 12, and this is 12, and this is 12, and this is 12. And I know that this is 7, which means this is 7, but it also means that this is 7, and this is 7, and this is 7, 7, 7. 7. How do I know that all of those are 7? Actually, no, I lied. I'm sorry. This is 7, and this is 7, and this is 7, and this is 7. These are actually 8. How in the world do I know that? Well, which means this is 7 and this is 7. If I fold this on top of itself, right? This side and this side are going to be shared. Like when I fold that up into the corner, that corner is going to be the same side. So if I draw this again, there's my rectangular prism, and this is 12, and this is 8. Then this top piece is 8. This is 8, and this is 8, right? And then this is 7, this is 7, this is 7, this is 7. So what we notice is if I were to flatten these back out, then it's going to kind of roll, right? So when I roll it back up, the sides are going to match with each other. I also know with a rectangular prism that the top and the bottom rectangles are going to be the same. And then the side rectangles are going to be the same too. So I know that I'm going to have 2 of the same of the top and the side rectangles, right? If that makes sense. So to find area, I'm going to do area equals length times width. So this one is going to be 12 times 8. This one is going to be 12 times 8. This one's going to be 12 times 7. And then these in here are going to be 7 times 8. And then surface area, I'm just going to add all of that up. So 12 times 8 is 96 plus 96 because I have 2 of them. 12 times 7 is 84. And 7 times 8 is 56. So when I add all of that up, y'all, I just have to say that I love that the iPhone calculator finally caught up with technology and like allows you to string together your entire equation rather than just doing one thing at a time. I don't know if anybody else noticed that, but I'm obsessed with that. So that all equals 472 feet, and that would be squared because we were finding area. Clearly, none of those answers are going to be correct because I wasn't solving for volume, which is what the original problem was written for, right? I was solving for surface area. And so my surface area is going to be 472 feet squared. But I just wanted you to be able to see the difference between volume and surface area and then be able to solve for that difference. All right, let's move on to problem number 2. Simplify. Bracket 32 divided by parenthesis negative 16 close parenthesis times 4 close bracket minus negative 8 plus bracket 2 times 9 end bracket divided by 3 equals. So this is order of operations all day. This is order of operations all day. So I know my order of operations is PEMDAS, but a PEMDAS with some partnerships where this is parentheses, exponents, multiplication, division, addition, and subtraction, where my multiplication and division are a partnership and addition and subtraction are a partnership. So once I solve my parentheses and my exponents, then I'm going to solve multiplication and division in the order it shows up. And I'm going to solve addition and subtraction in the order it shows up. So let's go ahead and apply this. I see that I have some bracket here with some operations I'm going to need to do inside. And I have a bracket here with some operations I need to do on the inside as well. So I am going to go ahead and write this problem by itself and then start to solve. So 32 divided by, I'm going to rewrite the entire thing so I don't lose any steps. 2 times 9 divided by 3. I am going to solve this bracket first. So I'm going to leave everything else the same. Literally leave everything else the same. And I'm just going to solve that bracket, which equals 18. 9 times 2 is 18. Then I'm going to solve this bracket. 32 divided by negative 16 times 4. Now, the negative 16 does have parentheses around it just to show that we're doing 32 divided by a negative 16, not 32 divided minus 16, which wouldn't make sense anyways, but they're just trying to show that. So I am going to do the division first. Even though it looks like multiplication is first in order of operations, this is one of those moments where I'm going to do the division and then the multiplication, okay? So 32 divided by negative 16 is going to give me a negative 2. I'm going to keep everything else the same. And I'm just going to erase this and solve for it. So 32 divided by negative 16 is negative 2. And negative 2 times 4 is negative 8. Now, what am I going to do? Now I have negative 8 minus parentheses negative 8 plus 18 divided by 3. These brackets can really be dropped at this point because there's nothing inside the bracket that I need to solve. So now I'm going to solve the 18 divided by 3 because I still have some division in this problem. So I'm going to keep everything else the same. 18 divided by 3 is 6. I can drop these brackets here. Negative 8 minus a negative 8. I'm going to simplify that right there. So I'm left with negative 8 minus minus creates a plus. Now I'm going to just solve my addition from left to right. Negative 8 plus 8 is 0. 0 plus 6 equals 6. So my answer is C. Questions about that? All right, let's go ahead and move on to problem number 3. A gardener wants to create a unique garden for their business. She wants to have a square that has a side length of 6 yards filled completely with greenery inscribed inside a circle that has plants planted in the remaining space. All the plants will use the same type of soil, which costs $6 per square foot. A quarter of the remaining space will have flowers planted at $10 per square yard. And 3/4 of the space will have shrubs planted at $22 per square yard. The greenery will cost $8 per square yard. What will the cost be for the soil and all the plant? All right, I want to start with, this is a lot of words for one problem. And this is where a lot of people would go, I'm checking out. I don't know how to do, I can't do this. You can, and we just have to chunk it. So let's chunk it together. A gardener wants to create a unique garden for their business. That sentence is not helpful. There's nothing in that sentence that is helpful to us. It doesn't give us a shape. It doesn't give us a cost. It doesn't give us any information other than the fact that we're creating a garden, right? She wants to have a square. I'm going to draw a square. I'm not even going to read any further. I'm literally going to draw a square that has a side length of 6 yards. Filled completely with greenery, inscribed inside a circle that has plants planted in the remaining space. So now I'm going to draw a circle. There's my circle inside my square. Filled completely with greenery inside the circle. All the plants will use the same type of soil. So the soil is going to be the same in the entire thing. A quarter of the remaining space, the only space that's remaining, are these 4 little cutouts. And it says a quarter of them. What is a quarter? And that vocabulary, regardless of what test you are taking, that vocabulary is critical for you to know. A quarter is 1 out of 4, 25 cents, a fourth. So a quarter is literally just one of these sections. So a quarter of the remaining space will have flowers planted in it. So I'm going to color this one purple at $10 per square yard. And 3/4 of the space, so all of these, will have shrubs planted at $22 per square yard. The greenery, that middle green section, will cost $8 per square yard. What will the cost be for the soil and all the plants? So I know that I've got a lot of steps at this point, right? I have to find the cost of the soil. Then I have to find the cost of the greenery. Then I have to find the cost of the shrubs. And you can do this in any order. Then I have to find the cost of the flowers. So the soil is the whole square. The greenery is the circle. And the shrubs and the flowers are those external cutouts, right? Another thing that I notice is this. What's so important about that? $6 per square foot. What do I notice about all of the other units in my problem? They are all square yards or linear yards. Now, I'm going to have to operate in yards and in feet. So I don't want to completely get rid of the yards. I just need to be able to convert within. So I know that 1 yard equals 3 feet. So 6 yards is going to equal, to get from 1 to 3, I multiply by 3. So to get from 6 to feet, I'm going to multiply by 3, 18 feet. So this is also 18 feet. So if I'm trying to figure out how much the soil is going to cost, if I'm trying to figure out how much the soil is going to cost, I need to figure out how many square feet this whole square is. Because remember, the soil is all of the plants. So I need to figure out the area of my square, which is going to be 18 times 18, because I'm dealing with square feet. $18 times 18, 324 feet squared times that $6 per square foot, $1,944 is the soil. And I am going to keep everything labeled that I do in this problem because this problem is 4+ steps. There are more than 4 steps to this problem, and I don't want to lose anything because it asks for what is the cost for the soil and all the plants. So I need to make sure I'm keeping track of all of that. Now, I need to find the area of my circle so that I can figure out my greenery, right? And my circle is the greenery and it is per square yard. So I'm going to go back to my 6 yards, right? If this is 6 yards, then this is also 6 yards, right? Both are 6 yards because this is a square. They told us that it is a square at the very beginning. How do I find area of a circle? Pi times r squared, where r is your radius. Again, this is another nugget of information that even if you don't need to know how to do this problem, this is the nugget of information that you're going to want to know how to do. My radius is going to be half of my diameter. So my diameter is 6. My radius is going to be 3. Pi is 3.14 times 3 squared. So 3.14 times 9 equals 28.26 yards squared. Again, watching how I'm keeping track of all of that. And then this is $8 per square yard. So times $8 equals $226.08 for the greenery. Now I need to figure out the cost of my little tiny sections, right? How am I going to find the area of those little tiny sections? I need to find the area of my square, subtract the area of my circle, and that leaves me with those sections. But the area of my square is not 324 feet. I mean, it is 324 feet. But I need to find the area of my square in yards because everything else is in yards. So, area of little tiny section equals area of my square in yards is 6 times 6, which is 36. So I'm going to do 36 minus my circle, which I already found, equals 7.74 yards. Now remember, that's for all 4 pieces. For just one of them, I'm going to divide that by 4. And that gives me 1.935 yards squared per piece, right? A quarter of the remaining space is flowers at $10. So if I multiply this times 10, I get $19.35. And then the rest is $22 per yard. So I can do 1.935 times 3 because there are 3 red sections. And now you're noticing why this picture is so helpful, because then I don't have to worry about quarters and 3/4 and all of that. I can truly just use my picture. So now I can do 1.935 times 3, which is 5.805 times the $22 per square yard. And that gives me $127.71 for the shrubs. So now I have soil, greenery, flowers, shrubs. Now I can just add all of those together. 1,944 plus 226.08 plus 1935 plus $127.71 equals $2,317.14. Now, the correct answer is not there, and that is because the answer choices, when I created this problem, I accidentally did a miscalculation, and so it created the wrong correct answer. So the correct answer is $2,317.14. That, y'all, was a long problem. Now, I do not anticipate that you will get a problem that is going to be that many steps in one. However, what I want you to get out of that problem is how we solved it and how we approached the multi-step problem, because you are bound to get a multi-step problem on your test. So that's what I really want you to get out of this, is how to solve a multi-step problem, not get hung up on the fact that that multi-step problem might have been too many steps, right? All right, let's go ahead and move on to the next problem. The figure below shows the route of Soni's trip from her house to the zoo. Soni travels 20 miles from point A to point B, 18 miles from point B to point C, and 4 miles from C to D. If she were able to travel from A to D directly, how much shorter in miles would the trip be? How much shorter in miles would the trip be? This is an interesting problem. So, if she were able to travel from A to D directly, how much shorter would the trip be? So we're going from A to D. And there's my route. How much shorter would that trip be? So what I know is that I traveled 20 plus 18 plus 4. And 20 plus 18 plus 4 equals 42 miles, right? 42 miles. Now, how do I figure out how much shorter that would be? Well, what I do know is that this is 20 and this is 4. And this whole distance is 18. And I'm looking for the hypotenuse of this triangle. But what I don't want you to do is I don't want you to guess on, okay, this looks like it's like 6. And so that makes this like 12-ish. And so because 12 plus 6 is 18. And so now I'm going to do a squared plus b squared equals c squared. And a squared plus b squared equals c squared. And then add the two c squareds together. If you can't think of anything else to do, you could do that to at least get yourself to an answer, right? Like sometimes we just have to play with it and we have to figure it out and we have to answer the question. We have to come up with some sort of answer, right? But here's the better way to solve it. What if I did this? What if I extended this out and I extended this down and created a 90-degree angle here, what would that do? That now creates a larger triangle that I can find an exact measurement of by extending that out. I know that this is 4, so this whole side is 24. I know that this whole thing is 18, so now I can do a squared plus b squared equals c squared, and c is the distance I'm trying to find, right? 18 squared plus 24 squared equals c squared. 18 times 18, because that's what a square is, 324. 24 times 24 is 576 equals c squared. 576 plus 324 is 900. Square root of 900 is 30. C equals 30. The question asked, how much shorter is the trip? How much shorter is the trip? 42 minus 30 equals 12. Now again, if visually you just couldn't see it and you had to arbitrarily pick numbers, you could do it and probably get an approximate answer that could probably lead you to the right answer. But our goal in these sessions is to show you how to do the problem, right? And so there are test taking strategies that you can use if you're absolutely stuck. Dropped my pen. But now you know how to solve the actual problem if you need it. All right, let's go ahead and move on to problem number 5. The length, width, and height of a rectangular prism box Y, respectively, are 2, 5, and 6. A similar rectangular prism box Z has a length, width, and height of 6, 15, and 18, respectively. The volume of prism box Z is how many times the volume of prism box Y? So there are ways that we can solve this mathematically, and there's ways that we can solve this not mathematically. So if I know it's a rectangular prism, which means I know that the volume equals length times width times height. So I can do 2 times 5 times 6 equals 30 times 2 is 60 units cubed. And I can do the same for 6, 15, and 18. I can do 6 times 15 times 18. And that gives me 1,620 units cubed. So how many times the volume of prism Z is how many times the volume of prism box X? I can do 1,620 divided by 60, and that gives me 27. Answer found. Now, what if I didn't have numbers? What if it said the length, the width, and the height of box Y is A, B, C? And a similar rectangular prism box Z has a length, width, and height of X, Y, Z. How many times is the volume if it's a similar box? Well, in that case, and what if it said it was the length was 3 times the length of one of the boxes, right? So I know that the length of these is 3 times. 5 times 3 is 15. 6 times 3 is 18. 2 times 3 is 6. So it's a similar ratio, and the length is 3 times more. then I automatically know that my answer is going to be 27 due to scale factoring rules. If the length is 3 times more, length is 3 times more, then I know the volume is going to be 3 cubed times more, because volume is units cubed. So if I take my linear scale factor and I cube it, then I can find my volume of my new shape. What if I said the area of a rectangle is 2 and 5, and the side length of a rectangle is 2 and 5, and the side length of another rectangle is A and B, and it is 3 times, more. How much more is the area? Instead of doing 3 cubed times, you would do 3 squared times, because area is squared. And so you can use that understanding of squared and cubed to figure out your scale factor, which is going to help you in problems where you don't have all the numbers. In this case, we had all the numbers. So it was very easy to solve using those numbers. But sometimes we don't have all the numbers, and so we need to understand scale factoring. We have time for one more problem. So we're going to do one more problem, and then I'm going to close it out by throwing it over to Dr. A. Which of the following formulas shows the volume of the image below solved for the height of the prism? If little h is the height of the base and big H is the height of the prism. So the first thing I'm going to do is I'm going to find any equation that is solved for height. So A and B are automatically out, because the V, volume, is not solved for height. I want to know solved for height of the prism. Big H, solved for height of the prism. Big H. So it has to be C or D. Now, I know volume of a prism equals area of the base times height. Height. Normally I do a little h for that, but in this case, height for the prism. H is the height of the prism. In this case, in a prism, I have 2 identical bases. 1, 2. Those are my bases. This is area of the base. How do I know that those are the bases? Because I have to have 2 of the same thing, and then everything else is rectangles. So this cannot be the base, even though it's actually what the shape is sitting on, because there's not 2 identical of them and then rectangles surrounding that image, right? I have 2 identical triangles with rectangles connecting them. And so that's why that is not the base. And the height of the prism is the connecting length between the 2 bases. So this right here is my height, my height, my height. Well, if area of the base is big B, my volume is going to be 1/2 base times height, area of my base times height of my prism. Now, if I solve for that H, I'm going to divide by 1/2 base and height. So big H equals volume divided by 1/2 base and height. And when I divide by a fraction, I really keep change flip. So that 1/2 becomes a 2. So I have 2V divided by BH, which is C. Questions about that? All right. I'm going to turn it back over to Dr. A. Let me know in the comment box if there's anything specific that you want me to go over in the upcoming weeks, and I will be glad to include it in my upcoming sessions. I'm going to turn it back over to Dr. A. I hope that y'all have an amazing week. I hope that if you are a mom, that you have an amazing Mother's Day. If you are somebody who wants to be a mom or desires to be a mom, I hope that you have an amazing Mother's Day too. If you're a fur mom or a dog mom or a hamster mom, or you're just a teacher who has so many kids that you're just their mom, I hope you have a happy Mother's Day too. Have a great weekend, and I will see you next week. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.